Hello, welcome to the third lab. Okay, today we are going to continue to measure two other aggregate properties, which is specific gravity and also absorption capacity. Okay, we need these two information for our concrete mix design. Okay, for the lab report, again, the lab report will be an individual lab report combining lab number 2 and this week number 3. Okay. The due date is October 26th for Monday groups and October 28th for Wednesday's group. Okay, so we have basically two tests, okay, to measure the specific gravity and also absorption capacity of coarse and sand. Okay. The first one is specific gravity and absorption capacity for coarse. Okay. Refer to experiment number 7 in our textbook. Okay. For coarse aggregate, we need to first save the coarse using number 4, and we reject all the materials passing it. Basically, we use only the particles larger than number 4 saved. Okay. And then we are going to remove the surface moisture of the coarse aggregate particles using a towel. Okay. So we can get saturated surface dry condition for the coarse. Okay. And then we get around 3 kilograms of saturated surface dry sample. Okay, so around 3 kilograms will be okay. Then we place the sample in a wire basket, and then we measure the weight of the sample underneath the water. Okay, there's some details which we'll explain in the demo. Okay, and then we get a sample and oven dry the sample overnight, so we can get oven dry condition. Okay, so we get 3 weight, SSD weight, which is B, the weight underneath the water with C, and then weight in oven dry condition. Okay, and based on these 3 numbers, we can calculate the specific gravity and also apparent absorption capacity for the coarse aggregate. Okay. For the second lab, it is specific gravity and absorption capacity for the sand. Okay. We also need to remove the surface moisture to get SSD condition for the sand, but the procedure is totally different from coarse aggregate. We need to use a hair dryer to dry the sand, and then we need to use a special cone to measure if the sand has achieved SSD condition or not. Okay, again, you will see the details in the demo. Okay, after we get a sand in SSD condition, we get around 500 grams. Okay, and then we put the sand in a special container. We call that pygnometer. The capacity of pygnometer is 500 milliliter. Okay, so we introduce the sand into the pygnometer, and then we fill the remaining volume with water. Okay, we also need to get rid of the air bubbles between the water and the sand. Sometimes it's not very easy to do. Okay, so we measure the weight, okay, SSD sand, and also the weight of the pygnometer together with the sand and the water. And then we dump everything into a container and oven dry the sand in the oven. Okay, so we get another weight, E. And based on these 3 numbers, we can calculate specific gravity and also absorption capacity for the sand. Okay, so here show you the equations. You can just go ahead and use it. And these some of the questions we need to discuss for your lab report. Why it is important to know the specific gravity and also absorption capacity of the aggregate. Okay, we need this information so we can do our concrete mix design. Okay, without it, we do not know, we cannot do the mix design. Okay, what is the 4 major moisture condition for aggregate? We have oven dry, air dry, SSD and wet conditions. Okay. And why we should use SSD aggregate in concrete mix design. Okay. That is because only under SSD condition, the aggregate will neither give out the water or absorb water from the mix. So we can keep the real water to cement ratio we want. Okay, so let's look at the demo.
Today I'm going to test my aggregate for two important properties, a specific gravity and the absorption capacity that we really need them for a good concrete mix design. But I need to submerge all the aggregates into the water a day before, at least 24 hours, to make sure that after drying the surface of the aggregate, I'm going to get the saturated surface dry condition. It means that I need to fill all the voids inside the aggregate with water, so it needs 24 hours to penetrate into the aggregate. For part 1, I need to use sieve number 4 according to the experiment number 8 in your textbook on page 564. I need the sieve number 4 because it's a borderline between coarse aggregate and fine aggregate, and also it helped me to get rid of the excessive water, so I can dry it. I can dry the surface easier. I need 3 kilogram, more than 3 kilogram of the sample. I mean the saturated surface dry sample. So I need to prepare a little more than 3 kilograms. So I'm not worried about the weight for now. Just sieve it, put it on the towels, dry the surface, and try and error to get a little higher than 3 kilograms. So what I'm doing now, dump my coarse aggregate. So I can use this sieve to drain the sample as much as possible, and then get rid of the particles smaller than the holes on sieve number 4. And dump it on the towel. And try to dry the surface as much as possible. So before the surface of the aggregate is dry, you see that it is shiny. So one sign that you get the SSD condition is it is in matte condition, not something shiny like this. So I try to dry the aggregate. If you want to see that the aggregate is dry enough, you can grab one particle of your coarse aggregate and try your best to dry the surface and see the color and compare it with the rest of them to make sure that all of them uniformly has dry surface. So it should be something like this. It is not shiny anymore. So I try to have all of the coarse aggregate particles like this. I need a container to weigh my sample, so it's a little bit wet. Make sure that I don't have excessive water in the container, and write down the number for the container, because after the experiment today I need to put all the sample in the oven and then come back tomorrow after 24 hours. And what I'm going to do is weigh my aggregate and container together. I need to subtract the number that I've got, today. So make sure that you have the number for your containers. So the weight of my container for coarse aggregate is 548.1 gram. And then re-zero it. And dump my dry surface aggregate to see if I got 3 kilograms. It shouldn't be. but I keep, drying more aggregate to get a sample with a weight of at least 3 kilograms. Okay. So I need 3,000, more than 3,000, so it is not that important to be right on 3,000. Just you need to write down this number, whatever it is, as the weight of the sample in SST conditions. So write down 3058.2 gram. The weight of my sample, coarse aggregate sample, in SST condition. And you need to, according to the instruction, write it down as parameter B. So write down B equals whatever you saw on the scale. And then we need to go to the specific type of scale. It has a water tank underneath to measure for the volume of the aggregate. I'm going to explain it there. So let's go to the scale. Okay, for this part I need a scale. As you can see, it's a normal scale. The only difference is that I have a tank full of water underneath, and it has a hook that's connected to this underneath of the scale, and whatever material we have in this part, the weight is going to show on the scale. So what I'm going to do is tear the scale first with a basket inside the water, because I don't want to measure the volume of the basket itself. I connected the basket to the hook and then tear the scale to make sure that I'm starting from 0 and then dump the aggregate in. So I re-zero the empty basket and then take the basket out of the water. I need to dump all the aggregate sample that is in SST condition into the basket. Just make sure to transfer all the aggregate particle. Don't miss any of them. And then put it on the scale. Make sure that it is totally submerged in the water, I mean the whole sample. Because it is possible to have some entrapped air between the aggregate, I need to agitate it a little bit to make sure that all the air bubbles come out of the aggregate. And then when the scale settles down, you can write down the number. As you can see, the number on the scale is less than 3,000 something, the initial weight of the sample. The reason is that when we immerse something in the water, it's going to be lighter, equal to the volume of the material that we submerged in the water. In this way, we can calculate the volume of the aggregate, because the difference between this number and that 3,000 something is going to be the weight of water that displaced equal to the volume of the material. So the difference is going to show you the volume of the aggregate. So the number is not fixed on 19240. You can write it down and then go for the next step. I need to take my sample out of the container and dump it back in the container. Just make sure that you transfer all the particles to be accurate. And I'm going to go to the oven to put it for 24 hours to make the aggregate in oven dry condition. So let's go to the oven. I have to set the oven for 110 degrees Celsius or 230 degrees Fahrenheit. So what I need to do for this type of oven is just press the start button, and right now it is 210. I just use the top arrow to set it on 230 and then release it. So right now the current temperature of the oven is 210, the green one, and it's going to reach 230 in a couple of minutes. I just need to put my sample in the oven. I just have one sample. I know which is which, but if you have your colleagues or your other students group, you have to definitely write down your group number, A, B, C, date, whatever you need on the container to make sure that you do not mix them up. So I just put it in the oven and close the oven, wait for 24 hours. I need to come back tomorrow, take it out, and then wait. And I'm report the weight of the container and the aggregate together. You need to subtract the weight of the container and get the weight of your sample in oven dry condition. Okay, let's go for the second part of the experiment, that is testing for the properties of the fine aggregate. For the fine aggregate, again, I have to submerge the fine aggregate in the water at least 24 hours to make sure that all voids inside the fine aggregate filled with water. I have a strategy to drain the fine aggregate first because it's going to take me a lot of time to drain the fine aggregate and then dry the surface. I'm going to show you with a hair dryer. So I can use two sieves, sieve number 100 underneath and sieve number 4, because I don't want any particles larger than sieve number 4, the reason why I use this. And I'm going to use sieve number 100 to drain the water as much as possible. And also I don't need any particles finer than sieve number 100. For this part I just need 1 kilogram of my sample. So whatever I have on top of sieve number 4, I don't need it. And whatever passed through the sieve number 100, including the water, again, I don't need it. And I try to drain my sample as much as possible because make it easier to dry the surface with a hair dryer. Just to have estimation of the amount of aggregate, I'm gonna weigh it. I'm gonna use another container because I want to have my container dry. Just put it on the scale, tare it. So I don't want the weight of this container, but it is 500 something, so need to re-zero it. So the weight is not 500 because I didn't zero it. The weight is 39.7, but anyway, I don't need it. I just want to have some estimation for the amount of it. I need actually 500 gram of sample, so maybe 10% more, around 550 above is going to be enough. Because it takes me a lot of time to dry it, I don't need to have that much, more than enough. So you have around 1,000 kilogram, it is more than enough. And I need to dump it here in this pan to dry it. I need to use a hair dryer and something to stir it. So I need to have SSC condition. As you can see, I have excessive water all around the aggregate. I want to get rid of it first. So use a hair dryer to dry it. It will take maybe 10, 15, 20 minutes to dry it. The only way that I can make sure that my fine aggregate is in SSC condition is using this small cone. I need to pour all the fine aggregate that I think is in SSC condition in the cone and then tamp it 25 times. Gently, I'm going to show you, and then pull out the cone gently and vertically. If the fine aggregate has the form of the mold, it means that it is wet yet. And if it is dry, and if I take up the cone and it collapses, it means that the aggregate is in SSC condition. For now, just dry the aggregate and then get back to you guys. Okay, I'm drying my aggregate, my fine aggregate, for about 20 minutes, and want to test it if it is enough. I mean, it is in SSD condition. As you saw while I dry my aggregates, I try to stir all around the container to make sure that the moisture of the fine aggregate is uniformly dry. But for the test, if it is in SSD condition or no, I just need to use this cone. So I just need to put the larger diameter on the bottom and try to hold it with one hand and then dump your fine aggregate in the cone. You need to come up a little higher than the height of the cone, and then clean all around the cone, and then use this tapper and tap it 25 times. But I don't want to compress it. I just release it. I hold the tapper 5 millimeters above the surface of the aggregate and just release it gently, and 25 times. Because it goes down, you can stop, for example, after 10 times and redo it. Okay, and then get rid of the excess of your fine aggregate. I'm going to pull it up. If the shape of the aggregate maintain the shape of the mold, it means that I need to keep drying my aggregate. If it collapses, it means that that's enough, and the aggregate is in SSD condition. So I gently pull it up. As you can see, it's nice and beautiful, like my cone. It means that I need to, keep drying and drying to make sure that all the surface of the fine aggregate is dry enough. Okay, I guess that the aggregate is in SSC condition, is dry enough. My reason is that the color turned into something lighter. The previous one was totally dark. I just try it to make sure that if it's in SSC condition or no. So like before, I have to fill it up with my fine aggregate. And tamp it 25 times with a tamper. And then remove all the aggregates around the cone. I'm going to take it up, and if it still has the shape of the cone, it means that it's not enough. I need to keep drying and then test it one more time. If it collapses, it means that the fine aggregate is in SSD condition. So gently pull it up and let's see. And it collapsed. So my aggregate, my fine aggregate in SST condition is ready. I just grab my container, weight, write down the number for the weight of it. I need 500 grams of my fine aggregate sample, and so here is my container. So I tear my scale because I want to have my the weight of my container itself. So the weight of container for fine aggregate is 38.8 gram, and I just tear it and bring the fine aggregate here. You can also check out the appearance of the fine aggregate. Just make sure that you don't have excessive fine aggregate on the scale, because I don't have them in the container. So it is more than 500. Just get closer to the 500. A little maybe higher, but not that much difference is necessary. So you can write down this number, is close enough. So 502.6 as the weight of the sample in SST condition. And now I need to use a pycnometer or beaker. So what I did yesterday was wash it up thoroughly and then put it on the oven, because I want to have it clean and dry. So I want to be accurate as much as possible. So excessive water inside a pycnometer or on the surface just make my numbers inaccurate. I need to introduce a bit of water inside a pycnometer, maybe up to here, and then I'm going to dump the aggregate with a funnel. I'm going to use this funnel. Hopefully my aggregate passed through this funnel. If not, I'm going to use a piece of paper to do it. Dump all the aggregate, fine aggregate, 500 something gram of sample to the pycnometer, and then there is a mark here that shows that the capacity, the volume of the material inside the pycnometer is right on 500 milliliter. But because when I introduce the fine aggregate inside the water and then add more water, there might be, absolutely, it has some air bubbles entrapped between the particles of fine aggregate. I need to get rid of them first and then get right on the number, and right on the mark. So what I need to do is just grab a little bit of water and then pour the water in up to here, dump the aggregate inside, and add more water up to maybe 90% of the pycnometer, so that 100% is in here that I'm going to show you. I'm going to be closer. So I'm going to get some water and get back to you. Okay, I'm going to pour a little of the water, gently. Don't want to, splash it on the surface of the pycnometer. That's okay, I can dry it up later, but it's better not to splash it, make it easier. So maybe a little more. And then I can use this funnel. Try to transfer all the particles of your fine aggregate, because we want to be accurate as much as possible. So there is a little bit of particles inside the funnel. I transfer them all. And as you can see, I have some particles that stick on the wall of the pycnometer. I can wash them down while I added water. So my mark is over here. So 90% of it maybe somewhere around here, a little higher than the neck of the pycnometer. And I try to wash all the particles of the aggregate while I add water, to make sure that I have them all in the designated volume, not beyond it. So I wash them down. I have nothing on the surface of the pycnometer, it is good. And then add the water up to 90%. So it's a good level for the water to start, tapping your sample. As you can see, as I move the sample, many bubbles come up to the surface. You can see it here better. So I need to agitate it, tilt it, invert it, whatever I can do for it. And the water level goes down even after a little bit agitation. So I need to add more water because the volume was occupied by air bubbles, not real water. It goes down, and then I can redo it. So as you can see here, I still have air bubbles. I continue, rotate it, tamp it to get rid of the all air bubbles inside. It may take take some minutes. You need to be patient and do it to be accurate. I'm gonna get back to you when it's ready. Just forgot to weigh the pycnometer itself. It should be weighted before introducing the material in it. I need the weight of the pycnometer itself. Fortunately, I have exactly the same pycnometer. I weigh it. The number is for the pycnometer is 177.1 grams. So I have the weight of it, and then I can write down as the parameters. I keep getting rid of the bubbles. Okay, I'm done with agitating and getting rid of the bubbles. I can see no air bubbles on the surface of the pycnometer. It means that I just have the aggregate and water that fill the whole capacity. And what I need to do is just adding more water, because the line is right over here. I need to add water to get to the line and then weigh the whole thing. You have the weight of the pycnometer itself, and then you can subtract it and play with the numbers. Okay, so I'm right on the line, and then weigh it. So I can tear the scale and then weigh it. It means the number is just the weight of the water and the aggregate. So the weight of the water and the aggregate is 819.4, so 819.4 gram. And if you want to have them all together, I need to tear it, and then the total weight of it, the pycnometer, the water, and the aggregate all together, 996.4 grams. As the final step, I need to dump all the sample with the water inside the container. I have the weight of the container, so I need to do it gently. The only thing that I need to be careful about, just transfer all the particles of the fine aggregate to the container. It doesn't matter if you add more water and then, transfer your aggregate particles easier. Because when I put the whole container in the oven, whatever water I added to the container evaporates. So it doesn't matter how much water you have in the container. I can, wash it down. And and then maybe use more water. And then I could successfully transfer all the particles of my aggregate in the container. And like my coarse aggregate, I have to put the container in the oven, wait for 24 hours to get the sample in oven dry condition, and then compare them for the absorption capacity number, and then use the formulas that you have in your textbook or in the instruction to get the specific gravity of it. So I just need to put it in the oven. And then get back to my sample tomorrow to weigh them and report the numbers to you guys. Okay, that's it for today. We could get the properties of the aggregate. I mean, the second part of the properties of the aggregate, that was specific gravity and the absorption capacity. Thank you, guys. Okay, you remember that we were here for the properties of the aggregate. We weighed our samples, for the fine aggregate and coarse aggregate in SST condition. And today, I just take out my fine aggregate and coarse aggregate in oven dry condition out of the oven after 24 hours, and they're ready to be weighted. Just make sure that I'm gonna put the whole thing, the aggregate and the container and the scale. You have the numbers for the container themselves, and you need to subtract it to make sure that you just have the weight of the aggregate in oven dry condition. So go ahead and weight it. For the fine aggregate, the weight is 522.7 grams, including the weight of the container itself. And for coarse aggregate and the container, it's going to be 3538.9 grams. So you're good to go, and just calculate for whatever you have in the instruction. You can refer to the textbook. It might be a little different. Just make sure that you know the definition for each parameter, A, B, C, and D. So make a decision if you want to use the parameter from the instruction that I provided, or you want to use the textbook and just use a parameter that defined in the source. And that's it for today. Thank you.
Okay. So yeah, based on this number, we can calculate the specific gravity for the sand and quartz, and also apparent absorption capacity for the sand and quartz. Typical value for sand and quartz for the specific gravity is around obviously 2.6, 2.7, or 2.8. Okay. For absorption capacity, around 2%, 3%, 4, or even 5% will be normal. Okay, will be normal. All right. So when you read the lab report, do not forget the details, such as how you can get SAE condition for the coarse aggregate, use towel to dry it out, and how you can get the SAE condition for the sand. You use the hair dryer, and also you use the corn to check if the sand has achieved SAE condition or not. Okay. Again, the due date for the lab report is October 26th for Monday groups and October 28th for Wednesday group. Okay, and that's it.